So setting up AI locally on your machine can be quite intimidating, right? Especially when you look at all this tutorial talking about expensive GPU and crazy hardware requirement. And that's why in this video, I'm going to show you how you can actually build a complete AI development environment on a much cheaper hardware. We are talking about no dedicated GPU, just regular Windows machine. So we're going to explore LM Studio, which is basically where we can download and run the open source AI model locally. And then we are going to connect it to VS Code using the Continue extension, which is a kind of like a free alternate to the Cursor and a GitHub Copilot. But here is what makes this video different. We are not just going to click through the installation step. I'm actually going to explain the AI concept that matters. Things like context window, temperature, quantization, model parameters in more practical way. And understanding this will help you to fine-tune your setup the best result for your specific hardware. And furthermore, we are going to walk you through step by step how to set this up, how you can configure it, switch between different models and find out which model works best for your specific machine. But first, let me show you what I am working with here. So here if I open my system spec, you can see I have 32 GB RAM, a decent work machine. And if you have 16 GB, that works too. Just stick with smaller models. My CPU is Intel processor, nothing fancy. And for the GPU, I just have UHD 630, which is integrated graphics. Basically no dedicated GPU here, everything runs on CPU. So these are typical home office setup these days, nothing special. So by end of this video, this exact machine will be running local AI that can generate code, explain the complex script, help with the debugging, all without sending single byte to the cloud. So with that being said, if you are interested, let's get into it. Alright, to get started, first thing first, we're going to navigate to LM Studio, which is basically a place where you can download and run the open source large language model into your local machine. So you can see the download page based on your operating system here. I'm just going to choose Windows because I'm using Windows. So feel free to choose whichever operating system you're using in your local machine. So I'm just going to click download and run the installer. So while this install, let me quickly explain why LM Studio over something like Ollama. So if you heard about Ollama, it is similar, but I find LM Studio is much more beginner friendly because it has a beautiful graphical interface. You can see exactly what is happening, change the setting visually, download the models with one click. Ollama is a command line based, which is some people prefer, but for this tutorial, LM Studio is going to be much more easier to follow along. Alright, once we have the LM Studio installed into our local machine, right here it is going to suggest to download a model. I'm going to skip this for now because I want to show you exactly how to choose the right model for your hardware. So let's skip that for now. On the advanced settings, turn on the developer mode and continue to the LM Studio. And here we are. This is the main LM Studio interface with welcome message. Great. So let me give you a quick tour what we are looking at here. So right here we have the chat tab. This is where you can talk to AI directly once you have the model loaded. Pretty straightforward, just like ChatGPT but running locally. And this right here, the developer tab. This is the most important one for our setup. This is where we're going to run the local server that VS Code connects to. And you can see the panel at the bottom. These are live logs. So when VS Code sends the request, you will actually see it appears here in real time. Super useful for debugging if something isn't working. Then here we have Discover, which is basically your model store. Thousands of free open source AI model that you can download. And we are going to come back on this one in a second. My model shows everything you have downloaded, currently empty because we haven't downloaded anything yet. So let's go ahead and download a model first. Alright, by choosing the right model is actually really important. If you pick wrong, your machine is going to struggle. And if you pick right, you get a great result with the minimal resources. So let me show you what I mean. So first, let's sort out the most download to see what is popular. And look at this, GPT-OSS 20B, over 1.3 million downloads. Staff pick, this is actually an OpenAI open source variant. Sounds amazing, right? So let me click on it and show you why we are not going to use this one. So right here you can see all the model details. So let me break down what you're looking at. Params 20B, that means 20 billion parameters. Think of it like a brain cells. More parameters generally means smarter, but heavier and slower. Format, you can see GGUF or MLX. GGUF is what you want for Windows. MLX is Mac only for Apple Silicon chips. If you are in Windows, always look at GGUF. And here the capabilities. This model has tool use and reasoning. Tool use means it can call the functions. Reasoning means it can think step by step. Pretty cool, right? Context 131K. That means this model can process 131 tokens at once. That is massive. And look at the download size, it's about 12 gigs, and see the badge, full GPU offload possible. That basically means this model is designed for GPU acceleration. For our CPU system with 32 GB RAM, this model would take like 10 minutes to just load, and it would use most of our RAM just sitting there, and generating response would painfully slow. So this is not the right choice for us. So let me show you how to find the model that actually work on a modest hardware. So what I'm going to do is search for Coder. These are models specifically trained for the programming skill. Now here you can see multiple options. QM 2.5 Coder, this is from Alibaba, really good for coding. DeepSeek Coder is another option. CodeLlama, this is meta coding model. Now let's click on the QM 2.5 Coder here. Alright, now you can see the QM 2.5 Coder comes with in different size. 7B, 7 billion parameters around 4 to 5 gigs. 14B, 14 billion parameters around 9 gig. 32 billion parameters with 20 gig. For CPU only setup, 7B is a sweet spot. It's smart enough to real coding tasks but light enough to run smoothly. And here is something important. You see instruct in the name? That's actually really important. Basically there are two type of models. Base models, these are just complete text, kind of unpredictable. Instruct model means these are trained to follow the instructions. For coding you always want the instruct. It's trained to answer your questions and follow your commands, not just randomly complete the text. And one more thing, these Q numbers here, Q4, Q5, Q8, this is called quantization. Think of it like image compression, right? Q4 is like JPEG, smaller file, slight quality loss, but run faster. Q8 is like a PNG, large file, best quality, but slower. So in a nutshell, for CPU only system, Q4_K_M is perfect. It is the best balance of size and performance. So I'm going to download QM 2.5 Coder with the 7B instruct with the Q4 quantization, about to 4 to 5 gigs. Much more reasonable than 12 gig monster we looked earlier. While this downloads, let me explain some quick AI concept that is actually help you to get better results. Alright, so next few minutes might be actually the most valuable part of this video. Understanding this concept will help you to fine-tune any local AI setup. First is context window. So context window is basically how much text AI can see at once. Think of it like AI short-term memory. If you set context window too high, two things can happen. First, RAM will fill up. Second, response will get slower because AI has to process more text. For CPU only system, I recommend starting at 4096 token. That's about 3000 words of context, enough of the most of the coding tasks. So in our settings, we'll set it as 4096 to start, and we can always increase later if we need to. Moving on, next big one is the temperature, which control the randomness. It's number between 0 to 1. Low temperature like 0.2 to 0.4 means consistent, predictable output. High temperature like 0.8 to 1 means more creative but sometimes random output. For code, keep it low between 0.2 to 0.4. We want our code to be consistent and reliable, not creative and surprising, right? Next, GPU offload. These settings control how much work your GPU does versus your CPU. Since we don't have a dedicated GPU, we set to 0, everything runs on CPU. If you do have NVIDIA card, you can experiment with higher values. More GPU offload means faster generation. Alright, let me check our model is done with the downloading. Great, now it's ready. Let me show you these settings in action. So now we need to make this model available to other applications, specifically for the VS Code. So I'm going to the developer tab here. This is where we can run our local API server. Then click on select model to load and choose our model we have downloaded. So before we load, let me show you the optimized settings we have here. So context is 4096, GPU offload is 0 since we don't have a dedicated GPU. Then I'm going to click the load model. So here you can see it is loading the model into the memory. After some time, you can see the status shows ready. Now the important part, starting the server. So right here you can see the status has stopped. I'm just going to toggle into the running, and here we go. You can see a URL, localhost column 1234. This is what VS Code is going to connect to. So let me do a quick test right here in the LM Studio first. So I'll go to the chat, make sure that our model is selected, and I'm going to just type something simple like explain what is Ansible in one sentence. And there it is, running completely locally on your machine. Notice no internet required for this response. The model is running entirely on your local machine. And if you're curious about what your system is doing, you can open the task manager and see. The CPU usage is pretty low, RAM usage for the LM Studio is reasonable, and most importantly, the network shows 0. That means nothing is leaving your machine. Alright, now let's connect this to VS Code. Great, so VS Code is where we actually write the code, right? Now we'll also connect our local AI. So for this, we are going to use Continue. It's completely free, open source extension that works like a GitHub Copilot. and it can connect to any AI provider, including our local LM Studio. So what we are going to do here is press Ctrl Shift X to open the extension. I'm just going to search for continue, and right here continue Codestral, Claude and more. I'm just going to select install. Now you might be wondering why continue over the other extensions. So basically it is completely free and open source, works with the local models, not just the cloud stuff, and it has a chat, edit and apply features like cursor, and it got really active development and community. Here we go, we got it installed. Now we can see there is a new icon on the sidebar now. Alright, so let's click on the continue icon here, and this opens AI chat panel on the side. And right here we need to tell continue where to find our AI. I'm going to click on add chat model, and look at this drop down. We have a bunch of options here. So let me quickly walk you through what you're seeing here, because this is actually pretty cool. So you can see OpenAI, that's a ChatGPT GPT-4. You know that is a popular one, but require API and cost money per request. Then we have Anthropic, that is Claude. Again, cloud based, require API and costs money. Then Google Gemini, same deal, cloud API. Then we have Ollama. This is another local options like LM Studio. If you have used Ollama before, you can connect it here too. Then Azure API for the enterprise setup. So you can see continue is super flexible. It is not locked to one provider. You could even switch between multiple, like use local model for everyday stuff and switch to the cloud API when you need something more powerful. But for our setup, I'm going to use fully local. I'm going to select LM Studio from the list. And beautiful, look at this auto detect on our model. You can see it found LM Studio community / the model we loaded on the LM Studio. This is because LM Studio already running on localhost column 1234. Continue just scan that address and found what is available. Pretty seamless. And you can see the configuration file. If you don't find this configuration file loaded automatically, go to the setting, then config, then click on this gear icon on the local config. So here is the working configuration look like. The key thing is auto detect. This means that continue will automatically use whatever model currently loaded in LM Studio. So you can switch the model in the LM Studio, say from 17 billion to 14 billion parameters. Continue will pick up the new one automatically. No need to edit this configuration file every time. And see this API base localhost 1234, that is where LM Studio is running its servers. Continue send the request there, LM Studio process them with your local model, send back the response, all happening on your machine. Pretty convenient, right? One configuration and you can swap the model anytime from LM Studio side. Alright, on the moment of truth, let me type something simple. Hi, explain Python in one sentence. And you can see it's generating, takes about 30 seconds on CPU. That's a trade-off for running locally. So what happened here? The question went from VS Code to LM Studio, process entirely on my machine, come back, no internet, no cloud, everything stays local. Alright, that's a basic test. Let's generate some real code now. Great, let's try to create some solid Ansible playbook using this. For that, let's type Ctrl N to create a new file. Then you can see a new file is created. Then you can directly write that code into that file. Then press Ctrl I to generate the code. This will open a chat window on the left side with a model loaded and the cursor positioned there. Now let's paste this prompt where I want to write an Ansible playbook for Cisco devices that will be condition based for the iOS and iOS XE, and save the backup file with the host name and the date. And let's see if we can generate this code for us. Press enter for the code generation. So while the code generation takes place, let's go back to LM Studio and click on logs under the developer tab. So in the LM Studio logs, you can see post/v1/chat. This is a VS Code knocking the door for your local servers. It carries your exact prompt, explain Python in one sentence, right? Immediately after that, you'll see the server pull the metadata and it confirms it is using the local model we just downloaded and applies all your custom constraints like max token as 4096, temperature as 0.3. Then you see the real work start. The log shows KV cache being allocated and token being adjusted. Since we have no dedicated GPU, your CPU is manually calculating the mathematical weights for every single words. So in a nutshell, this transparency is something you never get in cloud AI. You see exactly what is happening, when and how. And this is super useful for debugging if something isn't working right. Now let's come back to the VS Code, and you can see our code has been generated now. All the details, if you think it looks good, then you can accept it or continue asking more questions to fine tune our code. Then save it. Now I'll show you something more interesting. Instead of going like adding the file and generating the code, you can go to the chat window and ask. I'll put the same prompt again, and you can see it is not only generating the code, but it also gives a nice explanation about the code and also give some footnote and how to run the code, etc. And if you look at this code, and this is much more fine-tuned than the previous one, platform check and the date are incorporated. Now look at the CPU usage. You can see the load is shared between the VS Code and LM Studio application on the task manager. And the network usage still shows zeros on both as well as the overall usage. And the CPU is below 10% as always. Alright, so before we wrap up, let me share some quick tips and common issues you might running into. So first of all, the CPU only system like ours use 7B billion parameters instead of 14B. 7B is like 2x faster but not much quality loss. Keep the context at 4096 or lower. Higher context means slower response. And if you are not using autocomplete, disable it. It triggers constantly and can slow things down. Close Chrome or other heavy application while using AI. More free RAM means faster generation. Store your models on SSD if possible. Loading models from hard drive is painfully slow. So that's it. Now if you have a complete local AI coding setup running on your machine. No subscription, no cloud, completely private. If you found this useful, hit the like button and subscribe for more content like this. Drop the comments if you have any questions or want specific topic to be covered. I'll see you on the next one. Take care.